Good morning, class. Today we're going to work through a simple example of bringing input into our game. So we have an example game. I've gone ahead and set this up with a little bit of starter code that basically puts us at the same place we stopped with our hello world. So we're going to have a variable for a number of balls. Actually, we're going to use 3 balls in this example instead of 1. And in our initialize, you notice that we're constructing that array and constructing 3 balls. Notice that our balls are now in their own class. And let's take a look at that. So it's keeping track of the game it belongs to, a color that is going to be rendered, a texture 2D, and a position vector. And then we also have when we construct it, we take in the game and the color and set those. Our load content method uses the game's content manager to load the texture. And this particular texture is a basketball, and that was designed by Erick Sanez-Gardea for the class. It was very nice of him to share it. I tweaked it a little bit to give it a white background so that when we color it, that color will show up. But it's basically his work. And then we go ahead and have our draw method, which takes a sprite batch, and as long as we have a texture, we're going to draw using that sprite batch. So jumping back to the game, when we construct those, we're giving 3 balls with the color of red, green, and blue on top of the white background. That ball basically looks like this, so it's a white background. This green part is transparent. So that's going to color the ball with those colors. And then we put them at different positions. Notice we're just using that initialization syntax to set one of the properties, the position property, to be a vector. So this puts them in a row about in the middle of the screen. In the load content, we're iterating over all those balls and invoking their load content method, which is just going to go ahead and load this texture. Now notice they're all using the same texture, and that's perfectly fine. One of the nice things the content manager does for us is as we're loading those, the first time it loads and then the second time it uses a cached version. So this is actually very efficient, even though you might be thinking, oh, we're going and loading a file 3 times. We really aren't. So this is one of the nice aspects of that content manager, and we'll talk more about that down the road. Notice we haven't done anything in our update method, so unlike the hello world example, our balls are not going to be bouncing around the world, and that's because we're going to add input to control them here. And then finally in our draw, we invoke the sprite batch begin and end, and between that, we're going to invoke the draw method of the individual balls. So if we go ahead and draw this, or run this, we should see the 3 balls appearing on screen side by side, and now we're ready to start looking at what can we do input-wise with these balls. So all of our input is based on input polling. So we're going to populate a state object describing the current state of the input device, and we're going to store that and use that in our game. So we're going to start with keyboard input. So I'm going to create a keyboard input or keyboard state, and let's call this current keyboard state. And I'm just going to declare it like that. And then if we come down into our update method, right at the top is usually where we're going to deal with input. And you notice there actually already is some input stuff here where we're getting state from the gamepad and we're getting state from the keyboard, and we're invoking this get state. Now this is what we want to do, but we want to do this in a cached way. So we're going to actually have current keyboard state equals keyboard dot get state. And then because we've already saved this into a variable, we might go ahead and tweak this. So instead of invoking it again, we can just use the cached version that we have. And that way we're not going and grabbing it twice. So what this is going to do, this is a static class of keyboard and a static method of get state. And what it actually does when we invoke it is it will copy or create a copy of the current keyboard state, which is a struct. And then we're assigning that to this current keyboard state. So that struct just gets copied. The bits of it get copied right on top of the bits of this keyboard state structure. And essentially that's a structure being assigned a structure. They're both value types. It's a very fast bit-blit operation. So this is one of the reasons we're using a struct and not a class, is this way all the memory we're allocating stays on the stack, and it only exists for the duration of this update method, or in this case, because this is actually defined as a class variable for the life cycle of this class. So it's actually allocated as part of that class and just sticks around with it. So we're not allocating new memory, we're not freeing memory. It's just very convenient that we just keep copying over the same memory location. Alright, now we're going to do our update logic down here, and we might want to update our ball based on that keyboard. So we're going to use the very first ball, so ball 0, and we want to update its position. Or sorry, balls 0. And we're going to do that by plus adding, and because this is actually a property, we can't do .x plus equals. This will actually complain because this is not directly accessible. It's part of an object that we actually have to talk through. But what we can do is just add a new vector 2 to that, and let's start with changing the x direction. Say we want to move it to the left. That would be a -1 in the left direction, or maybe -100 if we want to move at the same speed that we did in our Hello World example. And then we'll go ahead and put a 0 in the y direction. So now this will take this vector, add to it this vector. Notice our vectors are also struct, so this is actually, again, utilizing that structure, the fact that it's a value type, to make this possible. So we're going to change that position, and we want to do that whenever we're hitting the left direction key. So with the current keyboard state, we can see if a key is down with the is key down helper method, and that uses the keys enum, and we need to tell it what buttons we're interested in. So this would be left. So if the left key is down, and we might also want to look at the W key. So we could do an OR here and say current keyboard state, or sorry, WASD keys, which would be keys.A, to do the WASD pad as well. And that needs to be an is keys down as well. Is key down, there we go. And I'm going to go ahead and drop this down a line just to make it easier for us to read. And what we would do in that case is just this transformation that we created. So basically, if we're hitting the left key or if we're hitting the down key, we're going to update that position. And we want this to be in terms of the time step as well. So we don't just want -100, we want -100 times our game time dot elapsed game time dot total seconds. And of course, this is going to complain because this is a double, and it knows that if we're assigning it to a float, we're going to throw away some precision. So we have to do an explicit cast to say that no, we're okay throwing away that extra precision. So now this is going to be 100 pixels per second. By multiplying it by this elapsed time, we make this per second. And so every time we're holding the left key down or the A key down, we're going to move left by that 100 pixels. And we can go ahead and do the other keys. So there should be 4 of them. We're going to do the key down for the left. Let's go ahead and do right. And the WASD equivalent for that is D. And in this case, if we're moving to the right, we're going to use a positive 100. Then we're going to do moving upwards. And that, of course, is a W equivalent in WASD. Now, in this case, the vector, we're going to not move in the X direction, but we are going to move in the Y direction. And this is going to be negative because in screen coordinates, up is the negative direction. And then, of course, we have to take off this trailing 0. And that's now going to move us upwards if the up or the W key is pressed. We'll do the same for the down and the S key. And in that case, it's going to be positive because we're going to be moving downward. And again, we're going to have to flip these and take out this extra 0 so that now we're changing in the Y-axis. Okay. Now we could also, instead of doing this scaling inside this vector, we could actually do it outside the vector to create a new vector of 0 and 100 and multiply it by the game time, elapsed game time dot total seconds. That would also work, but because we're really only changing this one value, this makes it 1 multiplication instead of 2, so it's slightly more efficient. Especially considering the fact we're doing it 4 times. But it really wouldn't be a big difference either way. So now if we go ahead and run our input example, Ball 0 is our red ball, so if we use the arrow keys, notice that now our ball can move around, or if we use the WASD keys. So now we're processing the input from that incoming ball and we're moving it around. Now let's do a little something special. Let's go to our ball class. Let's add a helper method, and we're going to call this public void warp. And what this will do is warp the ball to a random location on screen. So we want to take its position and we want to set it to a new vector 2 that is going to be a random position somewhere on screen. And in order to do this, it would be helpful to have a random number generator. And that comes from the system namespace, so we actually have that in place, so that's fine. And we'll say a random number generator. And if we come down into our initialization, we'll go ahead and create that. And finally, when we get down in here, we will do a x value will be a random next double. And that'll give us a number between 0 and 1, and we want to scale this to the entire size of the screen. Well, we can get that from our game.graphicsdevice.viewport.width. So by multiplying it by that, it's going to be somewhere in that width of the screen. And of course, this next double is giving us a double. We need it again explicitly cast that we're okay throwing away that extra precision. We're going to do the same thing for the y-axis. So random.nextDouble and multiply that by game.graphicsdevice.viewport, in this case height, because we're doing it in the y direction. So that's going to construct for us a new vector for that position. And I like to have my parenthesis line up like that when I do a function like this. So now if we go back to our example game, maybe we want this to trigger when we hit the space bar. So we might be thinking, oh, we can just do an if current keyboard state dot is key down keys dot space. And if that happens to be hit, we're going to call balls 0 dot warp. Okay, so let's go ahead and run this and take a look at what happens when we hit that space bar. So when I hit the space bar, notice that our ball kind of jumps all over the place before finally stopping in a particular location. And this is because when I hit that space bar, I'm actually holding it down for multiple frames. And the honest truth is, the fastest human being in the world probably doesn't have a fast enough reflex time to hold that down for just one frame. Like if I tap it just as quickly as I possibly can, we actually had a couple different spots it hit before it stopped. So I was maybe doing 3-4 frames there. So it's just something that we are not capable of doing. But what we really want in this case is probably a discrete action. So the movement was continuous, so from each frame, if we were still holding it down, we still moved it that much. But with a warp or with a firing a bullet or making a player jump, things like that, those are usually discrete actions. We want them to fire once and then stop. So in order to do that, we basically have to know not only this is the key down, but was it up in the prior frame? So we're going to have to add another state variable. I'm going to call this prior keyboard state, which will keep track of where we were in the last frame. And then if we come down to our update method, where we get this current keyboard state, we can also do prior keyboard state and set that equal to the current keyboard state, which is still the values from the last frame because we haven't gotten the new values yet, which we do in this line. So we take the old values, we copy it over the top of this prior keyboard state, then we grab the new values and copy them onto this current keyboard state. So now this is referring to the input from this last frame, and this is the frame before that. So down here, we can check to see if the current keyboard state has the space down, and in the prior keyboard state, was that same key up. And if that's the case, then we know the key has just gone down. If we want to know if the key has just been released, it's the opposite. We'd say is key up here and is key down here. So we'd look at the prior to see if it was held down in the prior frame, and in the current frame, has it been released. So if I run this again now, I hit that space bar, I'm just going to warp once every time I tap the space bar. So that gives us our keyboard input. Next, let's take a look at the mouse. So the mouse works in a very similar way. We have a mouse state object. I'm going to go ahead and create a current mouse state, and we can get the mouse state with current mouse state equals mouse. It's a static object again, and we can invoke get state on it. And that's going to return the current mouse state. Now the mouse state's a little bit different in that it has some different fields. It does have the mouse buttons, but it also has an X and a Y position, which we can extract from that. So let's go ahead and set our balls 1, so our second ball, and let's set its position equal to a new vector 2, and that vector 2 we are going to assign its values from current mouse state.x and current mouse state.y. And these are, as ints, so that's going to be perfectly fine. It will go ahead and automatically cast them for us. And now if we run this, we should see that as our mouse moves around the screen, our green ball actually follows its position. Now notice there is a bit of a lag here, and that's because the OS is not necessarily letting our game window know exactly at the very moment where that mouse is, because it's actually packaging up, sending that mouse event at regular intervals. So it's not maybe as accurate as we might want, but for game purposes this is perfectly fine, although we probably don't want the cursor to show up. So one of the things we can do if we're doing something like this is just turn the cursor off. So this is mouse visible property of the game that is in the constructor. We can set that to false. If we run that, now we don't have that cursor show up. So that's one possible way of dealing with that. Another way of dealing with it is we could potentially use the set our cursor itself. So that mouse object, we can also perform a set cursor operation and define a mouse cursor, and the mouse cursor object has a bunch defined as predefined ones. So for example, crosshair will give us a nice crosshair mouse cursor. So you see now instead of the arrow, there's a crosshair floating there. One of the other things we can do is we can actually construct a mouse cursor from an image. So we can say mouse cursor dot from texture 2D, and we could load a texture and put it in there. So we could actually make the ball itself be the mouse cursor instead of being a sprite that we're rendering in the game. So that's some other possible ways we could do that. I'm going to go ahead and leave this at false. Okay. And now if we wanted to do warping with the mouse, just like we did with the keyboard, we have buttons for the mouse, but just like the keyboard, we'll need to actually look at both a current and a prior state to make sure that that's a discrete action. So we'll go ahead and set prior mouse state. And if we come down here into right there, we'll do an if statement, very similar, current mouse state dot, and you can see we have the left button, we have the right button, we have a middle button, as well as a scroll wheel and some X button 1, X button 2 if you get one of the advanced mice that has extra buttons. But generally speaking, pretty much we can only guarantee we'll have a left button and a right button on most mice. So we can check to see if that is, and we have to compare it to a button state pressed, because this is actually being stored as a bit instead of being stored as a Boolean. And then this button state pressed is an enumeration of those possible bits, so pressed is 1 and not pressed is 0. So we're just going to do that check, and then we can say balls 1 dot warp, And right now, this is because we haven't done the second check with the prior state. This is going to have the same problem we saw before, where every frame we hold it down is going to be bouncing around. So to do that extra check, we'll just do an and prior mouse state dot left button equals button state dot released. And once we've done that and run it again, every time we click, looks like we didn't update the prior state. So we also have to do the same thing here, where we do prior mouse state equals current mouse state to wrap that prior current, what was the current frame, into being the prior frame at the start of this update. So now we should, when we click, it warps to a location on screen, but notice that immediately it goes back to where the mouse currently is, because that very next frame we update the position here. So basically we're warping for one frame and then just snapping back to wherever the mouse actually is located. So this is kind of worthless, but it showed the idea of how we can use those mouse buttons. So the next one we're going to take a look at is the Gamepad. And gamepads can look something like this, which is a Xbox 360 gamepad, and it's just plugged in through USB. We can also have a lot of other types of devices which register as gamepads. So for example, all of your Rock Band instruments will, you might have a steering wheel or a joystick that will register as a gamepad. So all of those basically map back to this gamepad state, which is an interesting kind of structure in and of itself. It's actually a compound structure, so unlike the other ones, it's actually made up of several substructures for the different buttons and thumbsticks and things. That way as you're running that, depending on the gamepad, different parts can be added or removed to match what the hardware actually has equipped. So we'll talk about that here in just a minute. The other thing about the gamepads is, again, this was designed originally for the Xbox 360, where you could have up to 4 connected gamepads. So there's an expectation that you might have more than one gamepad hooked up to the PC as well. And to get the gamepad state, then we would do current gamepad state equals gamepad, which is a static class, get state, but then we have to provide an index of the player we're interested in, so which connected controller. So the very first one's going to be 0, and then 1, 2, 3, and 4. In theory, we can have more than 4 connected, and there is, if we look at that static gamepad class, gamepad dot maximum gamepad count, which is a property. Right now this is 4. I don't know if it can be overridden. No, that's a read-only. So that's really determined by the hardware. And on a PC, at least for my PC, the default is 4, just like the Xbox 360. But potentially on other pieces of hardware, it may be set up differently. So if we wanted to actually track 4 gamepads, maybe we're having a 4-player game, we'd have to grab each one's state independently with its own index. And we'd probably change our variable names to reflect that as well, or use an array of variables. Okay. So with that gamepad state, we can, for example, do the buttons or the, let's say, the D-pad. So if we wanted to do the direction pad, we could say D-pad dot left button, and if that equals button state dot pressed. So this uses the same arrangement as we did in the mouse with the button states. So that would give us our left button, and that would be one possible way of doing that. So we could go ahead and do that out for the D-pad if we wanted to implement the D-pad. On the other hand, well, the other way we can do it is there is a is button down option there that we can take advantage of. So we could also say buttons dot left, D-pad left. And that would basically do the same thing. If that's the case, we'd want to do what we did up here for this one, where we set the ball's position to be scaled to the left and the right, and then all the other ones. However, there is the thumbsticks, which are also very interesting. So we could say gamepad state dot thumbsticks, which are these wiggly ones, and maybe we want to use the right thumbstick. We could say dot right, and that actually gives us a vector 2. So this is a vector between negative and positive 1, negative and positive 1 in both the x and y direction, which just happens to map exactly to what we want for a ball position. So we could actually say balls 2, so the third ball, and dot position, and plus add the current gamepad state thumbsticks right, and then that's going to move us to the left, right, up, or down based on that. Now, of course, if we want it to match what we were doing before, we're going to scale that by 100, and then we're going to scale that by total or game time dot elapsed game time dot total seconds. And again, we're going to have to cast this one to be a float to say it's okay to throw away that extra precision that comes with the double. And that should allow us to move around that ball with the thumbstick. If did I miss something here? We're getting the state there. Plugged in. Let's go ahead and just throw a quick breakpoint there. And if I look at the current gamepad state is connected as 1, so we are connected, we are getting those values in. And oh, I was using the left thumb pad, but I actually programmed it to listen to the right thumb pad. So there we go. Now the other thing you may have to do is you may end up inverting the axes if you want the y-axis to read the opposite direction. That's very game specific. You may also want to give the player the option of actually inverting that y-axis in the settings of your game, because a lot of players do have a clear preference that they're going to develop over time as to whether the thumbstick pushed up pushes the thing on the screen down or vice versa. And buttons basically operate the same way. If we want to have button state, we're going to need to have a prior state for the gamepad. And we'll come down in here and we'll go ahead and just do an if current gamepad state dot is button down buttons dot, let's do a, and current gamepad state dot is button up buttons dot a. That shouldn't be current, that should be prior. So was it down last frame, is it up this frame? And if that's the case, we'll call balls 2 dot warp to warp it to a new position on the screen. So now when I hit the A button, we are warping to a new location, and of course we have to make sure that we go ahead and set the prior state to the current state first, because if we don't do this step, then the prior gamepad state's always going to have that vector or that button at 0, which is going to be not pressed. So it registers as being a new press every round. So there, now when we just hit that button, notice we're popping around the screen like we'd expect. Now, if you don't have a gamepad of your own to use and you want to borrow a gamepad, we do have a couple in the department that I can loan out to you. Just let me know over Discord or via email, and we'll get that set up. For this exercise, go ahead and do this code. If you don't have a gamepad hooked up, so I'm going to unplug mine now, and we'll go ahead and run this again. Notice that it doesn't really cause any problems, because the other code still works perfectly fine. It will read the current gamepad state and basically set all those to 0 because it's not connected. So it's just now something that we can't interact with. So when you design your games, it's a good idea to design your games so that if they have a gamepad, they can use it. But if not, you have a keyboard fallback if you're doing kind of keyboard-based movement. That's pretty standard. In fact, anybody who's played a lot of games both on the PC and on the Xbox knows that it's usually everything we do on the gamepad we do with keyboard and mouse and vice versa. So you can write some wrappers to kind of deal with that. So that basically walks us through a lot of that. There are a couple other things to say about the gamepad's state especially. So with that gamepad state, if we go down into the buttons, we have all those buttons that we've seen, but there are a couple that are a little bit unusual. The triggers, for example, are actually going to give us, rather than being a button pressed enumeration, we're actually getting a value from 0 to 1, so a floating point number that indicates how far that trigger's been pulled. So this is not a digital input, this is an analog input where we can actually have a varying amount of pull in a particular direction. And that can be very helpful for certain types of gameplay. So certain buttons are sensitive that way. In the Xbox 360, it's really just the two triggers. The rest of them, I believe, are just regular old binary buttons. Also, the thumbsticks are buttons, so when you press down on a thumbstick, that's treated as a button as well. Okay. Also, if you're curious if the gamepad has a particular capability, you can do this get capabilities on the connected gamepad. And let's just capabilities. I'll put a breakpoint here so we can take a look at it as soon as we run it. And step over that, and now if we take a look at what's in that capabilities, notice that it's telling us that we have an A button, a B button, a back button, a big button, a D-pad. Basically, this is an Xbox 360 controller. It's a knockoff from GameStop, but it's a 360 controller. So it has all of these things that would normally be there, including things like voice support, which I've never actually used on one of these. So that can give you an idea of the capabilities. If you're building a game that needs certain capabilities, you can test to see if they're there, and if they're not, just throw an error or a warning or something along those lines. So that's good to know as well. And if you're using something like a Guitar Hero or guitar, note that the individual buttons are actually just mapped to those buttons. So usually the red button is going to be your B button, the green button is going to be your A button, X and Y are going to be your blue and gold respectively, and the other, the fret bars, I think, mapped to one of the thumbsticks, if I can remember. So there's basically it's all mapped to existing state in one of those. So if you do want to play around with the game guitar or something like that, just you're going to have to figure out what the mapping is and just take advantage of that. Okay. So this really isn't that hard. I think you get the idea. However, you may have started to think, wow, this is a lot of code to throw in here to be able to do all this input and a lot of stuff. And boy, this is going to really start to busy up my methods. And that's absolutely true. So one of the things you can do is you can create for yourself something like an input manager class. So let's go ahead and do that. We're going to add a new class. We call this input manager. Actually have one in that folder already. Go delete that real quick. I've done this work before. There we go. And now I should be able to add new class, input manager. And we're going to make this a public class. Because we're going to be working with X and A, I'm going to pull in using Microsoft.framework. Microsoft.xna.framework and Microsoft.xna.framework.input, which is where all the input state objects are declared. And now if we go back to our input example, just going to take all of this state, pull it out, and I'm going to put it in this input manager. And then all of this updating, I'm going to pull this out, and I'm going to put that into an update method. Public void update game time. So that's going to update our states, and then we just need to worry about how we're going to translate all of this. And basically I think what I'm going to do is I'm going to turn these into properties that we can get from here. So public, let's do a vector2 position. Yeah, I'm just going to do a single position, and get and protected set, or a private set, maybe private because this isn't going to be overridden. So basically what that does is this gives us an auto property, which is a vector2, and we can always get that vector, but because we've overridden the access modifier in the set, only this class is allowed to set that value. And let's go back here, and we're going to steal some of our update logic. And I'm actually going to start with the position from the Gamepad. And we'll create a new vector2 position and set it equal to the position that came out of our gamepad. Now if we don't have a gamepad connected or we're not using it, those are going to be 0 values. Then I'm going to do the keyboard. And here we will just use that position vector that we created. Actually, I think I could just assign, yeah, because we do have that being a public, a private property, I can set it directly here. So we'll just set that position property explicitly. And we want the warp stuff. Let's go ahead and just make a Boolean for that. So we'll have a public Boolean bool warp get private set. Actually, I want this to be direction, not position. So let's rename this. Direction, not direction. And that should have changed it down in here as well. And then here we are just going to set warp to true. We're going to do the same thing for the keyboard. If the space button is pressed, where did that keyboard space go to? Oh, right there. Nope, nope. Oh, that was the keyboard. Okay, so we're going to grab it from the gamepad. There we go. Yeah. Oh, this is not what I was trying to do there. Slow down, Nelly. There we go. And here we'll just set warp equal to true. So, and then I'm going to use some regions here. I don't know if you guys have seen this before, but the region is a nice way of organizing your code. So I'm going to say here warp input and close that region. So this basically creates a collapsible region that's labeled. So I can collapse this. That's lost my collapse button. Let's go ahead and do it here. State updating, region, all this, state updating. And this is direction. This just gives us kind of some extra labels. And if they were behaving properly, I think we have a error oh, that's why. That should be an end region. So each region needs to be matched with an end region, and notice that now these become collapsible. So we can actually go in and collapse the regions, and that makes our code a lot easier to kind of digest. We can just say, oh, here's where the code for these different pieces goes. And then, of course, we want to make sure that we're doing the XML style comments definitely on every public member and potentially elsewhere. So that updates our input manager class. We're going to need to create that in here. And we'll come down into our constructor and actually we could even do it up top because there's nothing special about it that needs anything to be constructed. But we'll go ahead and do it this way. And because it's a static class, it doesn't even necessarily need access to our game. And in our update, I'm going to do input manager dot lowercase I input manager dot update, and it wants the game time, which we're not actually using for anything in it, but we're going to go ahead and provide it. Notice that because we took that out, we're going to have to put back. Actually, let's go ahead and add to our input manager one more property for exit. And these are going to be false by default. Now, with Booleans, they always start at false, but we can also hardcode to just make it very clear that this should be false by in normal cases. This should also be false in normal cases. And we're going to add a region, exit, but. And inside of this, we're going to do the logic for exiting the game. So we're going to take this guy, pull that back out, put it in here, and then we're going to also tweak it. So rather than grabbing player index 1, and this is how XNA used to do it. They used a player index struct, which was basically placeholders for 0, 1, 2, and 3. MonoGame, because it does have the potential for more than 4 gamepads, has moved to just using an integer-based index, but both of them still work. We can just say current gamepad state dot buttons back equals button state pressed, or current keyboard state is key down, key is escape, and then we'll just say in that case exit is true, and we'll let that odd actual logic be processed in here. So if input manager dot exit, we're going to invoke the exit method of the game. And otherwise, we are going to update the position of, in this case, let's just update this ball, so ball 2 will set its position to be plus equal to input manager dot direction. It's going to move that ball times the 100 to get the 100, and then elapsed game time dot elapsed game time dot total seconds, and then of course we have to cast that to be a float, and then we'll just drop the rest of this. So we're now just controlling a single ball, and we're controlling it with our input manager. If we wanted to have more than one ball, then we could go back and play with that and make more than one updatable. But now we should be able to update that position with either the gamepad or the keyboard, and it does not seem to be doing so. So I must have missed something in here. Prior, you're invoking this update right at the top, so that should be happening. Do a quick debug, make sure we're getting in here. Looks like we are. And if we update those, direction, and now this current mouse state, direction is going to be 0, 0. Actually, I should be holding something down on the keyboard. Let's try this again. Oop. Held it down too soon. Okay. This is a problem of debugging in these kinds of games. It's a little bit tricky. Where did that stream of W's end up? I'll show you some other debugging techniques that we can use once we get to working with text. But for right now, keyboard state, direction plus equal. Oh, okay, I was still doing the scaling here. So if I'm doing the scaling here, I don't want to do the scaling here as well, because that's going to make our ball very, very slow. Not here. Where's our game? So in this case, the direction already has been scaled, so we don't want to scale it twice. Let's make sure, so we're scaling down there, but we weren't scaling here, so we need this scaling to be in place. Times 100 times game time dot elapsed game time dot total seconds, and cast that. So we have to be consistent. We can either do this kind of work in the input manager if it makes sense for our game, or we can do it in the update method, but we've got to do it in one of those two places. I'm still not seeing my ball, which is a little disconcerting. That should be working just fine. Let's try switching which ball, and let's try running this again. That ball seemed to be disappearing off screen. So that's our initial position, direction coming in at 0, 0. The plus equal should just be moving it. Let's go ahead and take that breakpoint out, take a look here. Our ball is definitely not being rendered on screen. Let's run this again, and we're going to throw a breakpoint in after the fact. So ball position, oh yeah, you can see there we're at a massively negative number, so we're definitely jumping off screen, which means somewhere in my logic I have made a mistake. So let's walk through this logic and just make sure that we know what we're doing. So prior to current, prior to current, prior to current, that looks fine. And now we get our direction we set to be the gamepad input. And let's go ahead and just take this, since we're scaling both of them, and drop it here. So we're going to scale the vector after it's created. And left and A, we're adding that number, and the same there. It looks fine. and space or A, we're warping, and do not see anything that looks problematic in there. So I'm not quite sure how we are getting so far off so quickly. We definitely are. What happens if we warp? Let's try. Let's just comment this out. Let's look at the warp and see what happens. Oh, looky there. So, we hit that button and we went flying all crazy like. What happens if we just hit our spacebar? Same thing. So that's suggesting that maybe we aren't updating that prior correctly. And so if we come in here, current keyboard state, set the prior keyboard state, prior gamepad state, current gamepad state. So that looked fine. Keyboard state. Down and up. Oh, yep, okay. Every time we come in here, we have to go ahead and set that warp back to false. And then we check to see if it's been set to true this frame. That should take care of that. There we go. Now that's behaving. There's the space. There's the gamepad. So that works as we expect. The real question is what is going on with our position? So let's just try only looking at the gamepad input first of all. And run this again. Oh, and I need to uncomment this position change. We are way off screen already. So our first frame through, direction is 0, 0. Our next frame through, direction is immediately way off the scale. And that is coming from, oh, we're grabbing the mouse state, not the gamepad state. That is exactly what it is. Oh my gosh. So we want this direction to be current gamepad state dot thumbsticks, and we were using the right one, so let's use the right one again. That makes so much more sense. So right here, our direction is 0, 0, our next step 0, 0, so that is exactly what we expect. So if we render our game, use our right thumbstick, there we go, we can control our movement, and I think keyboard still commented out, but if we go back and uncomment the keyboard, and run this again, now we can use the keyboard, WASD, or arrows, or the right thumbstick on our gamepad to move that around. So obviously, something like this, an input manager, part of the reason it's not bundled automatically in XNA is because it's very game specific, so we have to go and write the code that is specific to our game. However, you can see it gives us a nice way of abstracting multiple different types of controls and giving us just some very simple kind of state variables that we can pull out, properties that we can use in our input logic, which really cleans up this update method and keeps this game class from getting horribly bloated on us. So that's a really good strategy to kind of keep things manageable as you're working on this. And also by adding this abstraction, we can also change how our controls work without really having to do a lot of change in our game code, because now we're just looking at this interface we've declared, this direction and warp. So we can change what buttons trigger those. We can maybe change it into a button combination. If you're interested in doing some of the classic fighting games where you want to chain different button presses together, this would be a good class to actually handle those kinds of things in, and then say, oh, they've done the right combo for this particular move or something like that, and just treat that as a Boolean value. So this is a very handy way of thinking about the input in your game. And that wraps us up, so I will stop here. Go ahead and finish your code, commit that, push it, make a release tag, and add it on your assignment. Well, next time we're going to take a look at sprites.